So, what are we looking at today?
So I've got the changes we talked about last time. I wonder what would be the best way of. Maybe I will share it as a branch on my remote on GitHub. I was thinking we can go through it and maybe, if that's okay with you, you could review the changes. I can open a pull request promptly. I did not do it. There are 2 commits in that on that branch. Oh, there was main. So one changing the definition and another one adding the slot or other applicable changes.
Alright, so one, define PyAPI slot using Py by default. So I need to duplicate the definition. Right. Well, it's still internal because it has the underscore. Just
What would be better way to put it?
now that it's in the commit message, don't worry about it.
Okay.
But it's no longer only for the internal ABI. Because this suggests that the API is no longer internal. So that it is. Right.
One thing I realized after last time that I didn't really catch like the difference between include CPython mod support and include mod support .h. So I decided to leave it here because that was one of the possibilities in Python builds and tests pass. But maybe it would be better to move it to that other file. But then I don't know the rationale for that. When to stay, when to move.
Okay, so things that are included directly should be for the limited API. Things that are in include CPython should be for the rest of the public API. And include internal, the PyCore, that's for the stuff we don't want users to use. Right? So that's the rule of thumb, and there might be reasons to put different API in different headers. A common reason is because something is so something is a static inline function or macro that's used in public API, so the user's compiler needs to see it, but we don't want users to type the name directly because that might change. So that's the underscore py, right? That needs to be visible. So if it's like an include CPython, this needs to be visible to the compiler that the user uses, but it shouldn't really appear in user code. The reason why I put this one here is in this comment actually. So it's defined here so that the individual files that use this don't need to explicitly include PyCore mod support just to get this one macro, because presumably every definition of a module would need this. So it would probably be best to keep this. I'm not making suggestions, am I?
It's my fork, so you can't.
So what would I say here? Something like one important thing is that this needs what, C11, I think. Let's see what's new in C11. Maybe C99. Compound literals. That's the name. Right. So you can call a function with a literal struct like this, and that's exactly what we use. Here.
Mm-hmm.
Which means we shouldn't really expose this to users. Because while pep7 says Python 3.11 and newer versions use C11 and public API should be compatible with C99 and C++, this is basically the short story we tell users, right?
Mm-hmm.
If you use a compiler that can do this, you'll have no trouble. But we also support some compilers that don't really do this. And so every new feature basically gets added in a process where it's checked whether the common compilers can do it, and so on. Maybe something like this. Put it back. Yeah, I'll put in the PyABI slot.
Yeah, that would be just the rename of something that existed before, and the next commit adds to all the other modules. While except for free of those, yes, that's one of those. That's different.
Right, so this is a PyABI info var, which is defined somewhere.
It's defined in include mod support.
It's include. So PyABI var. Let's check. That's var. So static PyABI info. Looks good. so this is static, and we just check it. The module name, internal, and this is the same.
Oh yeah, now I see that
Link.
once I underscored it and the other one I did not. I'm not sure which one is the correct one, probably with the underscore.
So that depends on what's in the module def here. So this will create a module from this def, and the def has the underscore. Here we go on to create a module from tk intermodule. So that'll be the def, and that has the underscore as well.
Okay, so I had a typo in trace malloc.
There's a lot of ABI slots. And then there's one for readline. Yep. Yep.
I don't know if those are all modules. Like these very bad negative questions. Did I miss something?
Did you miss something? Okay, so how could you tell?
Yeah. I was looking for modules that define slots and a PyBuild core and not by limited API. And I did some git magic to determine. I'm not sure if the git magic was sufficient enough.
Well, what magic did you do?
Oh, I'm not sure. I would remember now.
So I guess easiest way is to search for PyModule def slot. There's something from the tutorial. It's in documentation.
And I limited my search to modules directory.
Oh,
might have missed something.
Yeah, there's probably a few modules in Python as well. Oh, test C API. I guess you don't need that. So right, so in PC there are some Windows only modules. There's just one WMI, MSVCRT, WinReg, WinSound. I don't know if you want to touch those. There's ASDLC, which is generated though. So if you really want to, you can change the generator. Although this one really should match. Some test stuff. There's a Python AST which is also generated, I think. Token IC which is also generated, hopefully. Context vars for some reason is in Python. warnings. Marshall. There will also be the sys module somewhere. Sysmodule.c. But I think that's created specially. Well, let's try this. So, how would you test this? I guess you could have a dict somewhere. Let's put a dict in the sys module. Every ABI check takes the module name argument, so it could put the module name in the dict, and then when the module is created, would check that there has been an ABI check. Is that worth the time?
Hopefully. It would be good to know it works.
So what's
that it does.
What's the API here? Okay, so PyABI info check. So what we can do here is where do we go for a global-ish dict? We could go to PySys, get object. PySys get out a string. There's a better one for that. PySys get optional address string. Right. So this gets an attribute from the sys module. The sys module is a bit special. So we give it a name, which will be checked modules, and it will store the result into this dict. So this is a double pointer. So we need to give it the address of a pointer, and if this fails, then something is wrong, and we return -1. Okay. So this can return -1 if something went wrong, if there's an exception set, 0 if the object doesn't exist, that's why it's optional, and 1 if the object does exist. And result can be set either to null if the object wasn't found or there was an error, or to something else if the object was found. So there's kind of a bit of overlap between the return value and this. So the way I like to use it is check for the error on call, and then if this thing is null, then do whatever we need. That means create a dict. I think that's just PyDict new. If that is null, then that's a problem. And then we set it, this PySys set object. Set it under this name. There. And if that failed, we're in trouble again. Right? Now reference counting. So PySys get optional adder string gives us a new reference if we have it. This gives us a new reference as well. PySys set object doesn't have a note, so presumably it borrows that reference normally. So here we should have our check modules, right? So that it's not null. And what do we do with it? It's a dict. Well, we can do a PyDict check just to make sure everything's going fine. Right? Nobody else should be messing with it. If I was putting this in a pull request, then of course I can't do this because this users can change this as modules from Python, so this would blow up. But it's just for the test. This is okay. So what then? Then we go to PyDict, and one of the PyDict set item variants. So there's a bunch of those because it's very old API and all the conventions changed over time. So there's PyDict set item, which sets a dict's key value, key to the value, well, entry. And there's the set item string variant, which takes a C string. So I think we want this one. So our dict is this, our C string is the module name, and I guess we can just put true in there. Might have been a set. Oh. Ooh, I haven't gotten true in a while. True, right? Subject has no method and is immortal, which means that as a CPython implementation detail, I don't have to worry about reference counting. Okay, so if this failed, then we're in trouble. Now the only thing left to do is reference counting for this check module. right? So it was created either here or here. If it's null, then we don't have a reference to it yet. If we didn't set it to sys, we need to decref it. If it's if we're returning here, we need to decref it. And when we're finally done with it, we need to decref it. So this should be the way to do stuff. Let's hope it compiles. Oh, compiles. Some tests pass, so this is good. And now we need to check this in wherever a module is created. So where would that be? So there's a module object.c. And there's a PyModule new object that is called by PyModule new. The object probably refers to the name here. Yeah, and then there's this helper new module node track that creates an object but doesn't really even set a name for it yet. So we need something a little bit more high level. And where is this called? So new module, it's module init dict. That sets the MD name here. But I think this will get called for Python modules as well. So for modules created from the CPython, we need something like PyModule create initialized. So this is single phase initialization. So this calls PyModule new. Is it? Oh, maybe it's all. Maybe this is the code path for everything. Right, so this calls PyModule new with the name. Is PyModule new called anywhere else? So PyModule new object is called in module from def and spec. So new is called from create initialized, which I think is single phase initialization. And module new object is called from multi-phase initialization with the slots. And new module here would be called from TP new of the module object itself. So that's from Python. Right, so looks like the entry points we want to watch are these two, and one calls the other, so we want to hack in here. And we get name as a Py object, but hopefully this is a string. Okay, so let's go. UTF-8 would be pyunicode as UTF-8, the name. If that failed, then we're in trouble. Now we need to get the dict from the sys module, so that's whatever we did here. And now if check module is null, that means we didn't get any ABI check before this, so we raise an error. Or maybe, well, we can either raise an error or we can get use PySysGetAttrString, which will raise attribute error or something like that. And it has a very different signature. So this one doesn't have the 3 states to return, so it just returns an object or null. So it's a bit simpler to use. And then if this is null, then it raised who knows what kind of error it raised, but some kind of error. Right? And now we need to, now we have a dict, we can assert that again, like here. And we need to check if that dict contains something. We have CPy for pydict contains string, yes. Okay. So I guess this can return -1, 0, and 1. Yes. Let's try switch then. Of course I don't want the name here, I want the name of the attribute from the sys, right? So if this was -1, then we're in trouble. If this was 1, then we're good. Do nothing, right? But in C we need to do the continue thing. Remember that? So in case 0, yeah, this is our error case, so we do pyr set string or pyr format module ABI was not checked, %s, and we give this name UTF-8 and return -1. So in C we can leave off this return -1 and it'll fall through. Remember?
Yep.
And one thing we can do is, what about all the other cases? Pydict contains string should only return these 3, but it's always nicer if the switch covers everything that could happen, especially if there's an error case ready. So I'll rewrite this to default. And hopefully that'll work. Oh, this returns PyObject, so it should return null. Not is this? Oh, Pyre format needs the exception type first. So this is somewhere in C, so we'll raise a system error. And there was a warning. And the warning is this statement may fall through. So apparently in CPython we have things configured so that if you leave off the break here, you get a warning, which is great. So we can either return null here, or we can use py fall through. I think that's the spelling, yes, with an underscore, which does some kind of compiler specific thing that disables the warning. Right.
Oh.
Failed to create a module object. Python init error. Failed to create a module object. So apparently we're creating some module so early we don't even have tracebacks ready yet. So what do we do? Let's just go for printf. Okay, we have an error somewhere. And this sucks because we don't get a proper traceback. So this says failed to create a module object. Where is this? This is in sysmodule.c. Aha. 4313. So this calls PyModule create initialized. So this is a function called pysyscreate. So let's okay. So one thing I did before. Let's go step by step. I ran make, which compiled stuff, and then make runs this freeze module program, which is basically a very trimmed down version of Python, which cannot import anything, and it's used to it's used for some steps in the build process. So if you mess something up at a very deep level, make will fail at this point, and because make is usually parallel, well, at least mine is, you get several of these at the same time with the same error, and it's a bit confusing. So you can do make J1, that'll only run one of them, or you can just look at whatever it ran. I like to run it a few times just so I only get the failing ones, and then I just copy this and run it, and I see there's an error there, right? So this freeze module, there's also Bootstrap Python there, Python in various stages of completeness, just so we can use Python to write Python. So freeze module will compile the getPath module into this header file.
Yep.
Oh, this module into this header file, So we can run GDB. Oh, I have a helper for that. So what will work on your machine is GDB --args. And here we can set a breakpoint at the function PySysCreate and see what's happening inside, right?
Mm-hmm.
So it's better to have this side by side. So I think this PyModule create initialized will blow up. Let's see. Do next a few times. So PyImport init modules does some preparation. Then we do PyModule create initialized, and we fall into this if, which means there's an error.
Yeah.
What error it is, we don't know because we're very early on and we probably don't have traceback machinery yet. So what do? We run the program again and step inside. And now we're in PyModule create initialized, which was the one that called PyModule new, right? Yep.
Mm-hmm.
And you can probably tell what the problem is right now. We are creating the sys module here. And up here we added, please give me the attribute of the sys module. Right? That's a bit of a problem. So yeah, we can go on. So there's PyModule init, check API version, module slot, some resolve thingy, then we go into PyModule new. So I step into that. This one. Get a PyUnicode from string. Call PyModule new object with it. Gets me here. I do get out a string and check modules is 0. Right? So what do we do? Probably special case sys. Probably don't need to check the API of sys. That's always compiled in. So how do you compare whether name UTF-8 is equal to sys?
Well, can we just like compare it literally? Yeah, something like that. Or
well, this is a pointer. This is an array somewhere in memory to the bytes SYS0.
Okay.
And you could have two places in memory that have the bytes SYS0. And they are probably different, right? So we're comparing pointers here. So this is the same as if you would do like is in Python. So we cannot do this. You need to compare character by character, which is what the string compare function does.
So we can take a look at what stays at the pointer in that address and take the look whether it's.
So strcmp basically goes character by character. Compares them and gives us the the difference of the first different character. So if this is 0, they're the same. this, if this is not 0, then we do this whole thing.
Mm-hmm.
The return value of string compare is 0 if they're the same, negative if they're if one is less than the other, and positive is if one is greater than the other. There's a very nice algorithm that leads to this. Basically, you go character by position by position, and if the two characters are different, you subtract one from the other and return that. And of course, if you get to the final 0 in either of the strings, then you return 0.
Clever.
Yeah, but then you have this, this doesn't really. Now this means, yeah. So if this is 0, they are the same. If it's not 0, they are not the same. So this probably could. Let's see. Can't initialize sys module still. Okay. Oh, source file is more recent and executable. Did I not save it? That sucks. Ooh. Oh. Running something else. Should be running this freeze module. So what is name UTF-8? That's sys. Okay, what is this sys? Let's step in. Okay, so we're in assembly now. So let's step out. How do you step out? I don't know. Let's run it there and run this again. Oh. Got through here. Okay. This went through fine. So we continue. And we go to what module is next. Sys.monitoring. Ah.
Okay, and that one should not. Yeah.
So, do we have checked modules?
No.
No, because I guess we don't have sys yet.
No. Ciao.
Okay. Well, that's fine. So I just put the printf here as well. And yeah, I forgot the \n at the end. Every printf. Here we go. No check modules for sys monitoring. Right, now we can expand this if thingy. This, and at the same time it's not sys.monitoring. I wonder how many cases we'll get. Sysjit. That's a module as well. Wow. Built-ins. That's another special one. Still definitely something where we don't need to check ABIs. And where did we get now?
Frozen import lib.
Frozen import lib. Aha. So frozen modules go through here as well. So we can either change the way frozen modules are compiled, or let's see where this error comes from. So I want to make a breakpoint here. And what's the backtrace here? So there's py import frozen module. I guess we could do the ABI check in here for this module, right? Frozen module name. So how did you do it in your pull request? Or
yeah. Another one. Look for var, maybe. Oh my god, it doesn't work.
Doesn't load everything.
Yes, here.
This one.
With a comment.
When you try to copy something from GitHub, it's horrible.
You can always try to copy from Pagir. It's even better.
Okay, so this thing.
Yeah.
Put in the name. Let's hope this doesn't fail. Should really be some error checking around this, right? Return.
Imp.
Name error. Name sys is not defined. So yeah, exception ignored in the internal traceback machinery means that somewhere the name sys is not defined where it should have. Now this is because the internal traceback machinery is trying to make sense of this error while we don't even have import lib up yet. So this is just misdirection. And here we go. Module ABI was not checked. _imp. Right, so this is a module that's defined somewhere somewhere you wouldn't have guessed. And I think it's in import C. Yeah. Here it is. A little imp. So let's put in this one. Yeah, here's one you need to put in. So import Python import.c defines the imp module, like an internal implementation detail. Underscore warnings. Now we're getting to the actual issues. So Python warnings.c. There's one. Marshall, yeah. I think we found that one with the grep. Marshall.c is for historical reasons. Also in Python. We have two now. Oh, main. Well, I think that one goes right in our list of exceptions. That's a very special one. Underscore staffed. Where's that one coming from? Modules stat.c.
Wait a moment. I'm pretty sure it used limited API. Not sure anymore. Maybe just an overlook on my side.
So we're running out of time here, but
Okay.
I hope this was interesting. Try to make it interesting.
Yeah, exactly. That's why it wasn't there, because it's using limited API. I'm pretty sure.
I see. Okay.
So that's like an exception, but a good one.
Right. Well, it's I don't know, that's probably another one then with the limited API, right?
That's one of...
I don't know, module.c.
Okay, that one is an overlook.
Okay.
Or not. No. It also uses limited API. Yes.
I don't know how to do that automatically. Context vars. Oh, that's...
Well, that would also be API.
Oh, yeah, that's also in Python. Okay, how much did you follow? Do you need any code from
me? I can go through the rest of it. I can devise this check in my own copy of Python and run it to the end. And see what's going on there.
Okay, so I'm making a commit called tmp.
Okay.
Pushing it into my branch under the same name as yours.
Okay, thank you.
And yeah, good luck. Hopefully that was interesting.
Oh yeah, it was.
I see I haven't started the recording. But it's recorded, I'll just upload it. Okay, so see you next week. Thank you.
See you. Bye-bye.